Hi, and welcome to everyone's favorite geometry hour, or geometry 7 minutes or so. Today, I am going to find a clipboard. Here we go. I'm going to talk to you about probably the most exciting thing to me that we've done so far in geometry this year. At this point, you guys have a base of knowledge that has actually expanded quite a bit, whether or not you realize it. And you are starting to know the things that are going to help you do actual real proofs that actually feel like real proofs. So let's get started with a reminder of some of our vocabulary words that we've learned lately. We've got supplementary, vertical angles, linear pair, and complementary. All right, so you'd have to draw, you have to draw a line to connect the word with the picture that best represents it, or the number that best represents it. Okay, so supplementary. Are those angles pairs 90 degrees? Do they look like this? 180 degrees? Do they look like this? So which one's the one that pops to your mind instantly? Because actually, this one might have more than two ways of describing it. Supplementary, just by definition, 180 degrees. All right, vertical angles. Another pair of angles. Vertical, remember the root word of that is vertex. So the vertical angles share a vertex together. And let's see, do they make a 90-degree pair? Is it meeting at a vertex like this? Is it meeting at a vertex like this? It's this one down here. The vertical angles meet at a vertex, and they're the angles that are kind of opposite one another. The ones across from one another. A linear pair, that one is kind of an easy one to remember because it's a pair of angles that are formed that share a line together. So it's this one right here. You've got this line that they share, and as soon as it's crossed by this ray or line segment or anything, then it's this pair of angles right here. Okay. And then last one is the word complementary. For two angles to be complementary, the number that should pop into your head automatically is 90 degrees. Whoop. All right, so there you have it. There's your brief review. So let's move on to these exciting new theorems. I think the coolest thing about them is that you actually will be able to draw your conclusions. You'll be able to finish these theorems by yourself. Okay, so if two angles are a linear pair, then they are. Now, we're going to fill in this blank. And what I've done here is I've drawn a couple different examples of linear pairs. Angles 1 and 2 are a linear pair over here. Angles 3 and 4 are a linear pair over here. And I think you can kind of imagine where we're headed with this. So you've got a linear pair of angles. One thing that you can say about them is that they share this common side, right? What do their angle measures have to add up to? And I think you'll realize they have to add up to 180 degrees because that's how far this semicircle is. And two angles whose measures combined are 180 degrees, that's just by definition, supplementary angles. Okay? Now, so that's the first theorem from this chapter. It's chapter 3, lesson 5, I think that we're doing. And Keegan is making an appearance. Hi, Keegan. Yes. All right, go away. All right, the next theorem that you'll be able to finish is theorem 8. Okay, if the two angles in a linear pair are equal, then each is blank. Okay. Now, I've made some examples of linear pairs here, and I want you to think about which one of those shows angles that are equal. Is it 1 and 2 that look equal, 3 and 4 that look equal, or 5 and 6 that look equal? I think you'll be with me that it's 5 and 6 that look equal. And not only do they look equal, your brain should be sparking this word right now. They look like they each measure 90 degrees, right? So if two angles in a linear pair are equal, such as 5 and 6, then each is a right angle. Okay, awesome. So that's the second one that you can just figure out just by the things that you already know. Okay, please stop. Next, we've got our final theorem for this lesson. And this one says, is Theorem 9. If two angles are vertical angles, then they are blank. Now, 1 and 2 here are vertical angles. And I think that a lot of you probably already know how the angle measures of 1 and 2 are related. But I just want to walk you through some quick things. Okay, first of all, if I'm just going to create this I'm going to call or name this other angle 3. Okay, now you'll notice immediately that probably, or hopefully immediately, that 1 and 3 form a linear pair, and that 2 and 3 also form a linear pair. Now, this is where you should start thinking. You're like, wait a sec. Oh, and I threw it across the room. Hold on. You just learned about angles in a linear pair, right? You learned that if two angles are in a linear pair, then they are supplementary. Yeah? Now, so these two angles, you know, are a linear pair, and these two angles are a linear pair, right? So 1 and 3 are since they're a linear pair, from that theorem back there, you know that 1 and 3 are supplementary. You know that 2 and 3 are supplementary. Yeah? Okay, now I'm going to take you back to a flashback. Supplements of the same angle are equal. That was Theorem 6 from the last section. Now, you know that 1 is a supplement to 3, and 2 is a supplement to 3. That means supplements of the same angle are equal. So if two angles are vertical angles, then, so since 1 and 2 are the vertical angles here, they're both supplementary to 3, that means they are equal. And I'm guessing you're going to start to see our proofs in class coming together really easily now that you have a little more information to work with. That's all for this lesson, except for final quiz. Definition: rays AB right here and AC right here are opposite rays if and only if. And this is the definition that we learned sometime this chapter. But let's see if you can figure it out. Rays AB and AC are opposite rays if and only if BAC. And there you have it. Thanks for joining me today. I will see you in class on Friday. Your new homework is Chapter 3, Lesson 5, Set 1. So I'll see you Friday. I do have a few questions that I received in email that I'm going to email out the answers to everybody. Thanks. Have a good week.